Welcome dear students to Standard 10 Geometry, Chapter number 7 Mensuration. This is teacher Sharon Visselba. Mensuration is a part of geometry concerned with ascertaining length, area and volume. Certain applications in daily life, amount of paint required to cover a certain surface area, amount of carpet required for a particular room, fencing needed for the perimeter of a garden, volume of soil needed to fill in a ditch, the distance around a circular racetrack, travel and road map reading, amount of fuel needed for a given journey, gift wrapping, finding capacities of containers, tanks, etc. All these can be found out by using formulas or by using information given in this particular chapter. So let us start. Last year we have studied surface area and volume of some three-dimensional figures. Let us recall the formulae to find the surface areas and volumes. First one, cuboid. Lateral surface area is equal to 2 multiplied by height in the bracket length plus breadth. Total surface area is equal to 2 multiplied by in the bracket length into breadth plus breadth into height plus height into length. Volume of a cuboid, length multiplied by breadth multiplied by height. Next is a cube. Lateral surface area of a cube is 4 into length square. Total surface area of a cube 6 multiplied by length square. And volume of a cube is length cube. Cylinder. Curved surface area of a cylinder is 2 pi radius into height. 2 into pi into radius into height, that is 2 pi rh. Total surface area of a cylinder is 2 pi r multiplied by r plus h. Volume of a cylinder is pi r square h. Cone. Slant height L is equal to under the square root height square plus radius square. Curved surface area of a cone pi r L. Total surface area of a cone is pi r in the bracket r plus L. Volume of a cone 1 upon 3 into pi r square h. Next is a sphere. Surface area of a sphere is 4 pi r square. Volume of a sphere 4 upon 3 pi r cube. Hemisphere, curved surface area 2 pi r square. Total surface area of a solid hemisphere 3 pi r square and volume of a hemisphere 2 upon 3 pi r cube. My dear students, you need to memorize these formulae, so please write it multiple times and you should know all these formulae because these are going to be, you are going to use them to solve certain sums. Now there is an activity given in your textbook on page number 142. We are going to discuss this activity. So please have a look at these figures, figure 7.4, figure 7.5 and figure 7.6. As shown in the above figures, take a ball and a beaker of the same radius as that of the ball. Cut a strip of paper of length equal to the diameter of the beaker. Draw two lines on the strip dividing it into 3 equal parts. So this is the ball of certain radius. The cylinder, the radius is the same. We have taken a strip, cut it into 3 parts and we have stuck it on the side of the cylinder. Fill water in the beaker up to the first mark of the strip from the bottom. So we have done that as well. We have filled this much water. Push ball in the beaker slowly so that it touches its bottom. So we have pushed the ball inside. Observe how much water level rises. You can see water level has risen so much. That is total is 2r. The diameter total is the diameter of this particular ball. You will notice that the water level has risen exactly up to the total height of the strip. Try to understand how we get the formula for the volume of a sphere. The shape of the beaker is cylindrical. Now pay attention. Therefore, the volume of the part of the beaker up to height 2r can be obtained by formula of volume of a cylinder. Let us assume the volume of cylinder is V. Now V is equal to pi r square h, that is the formula for volume of cylinder. Now in this case, height, this much is the height. We want only volume up till here. So height is 2r. So instead of h, I am going to replace h by 2r. So now my formula is pi r square multiplied by 2r. Now r into r is r cube. So now I get 2 pi r cube. Now this is my V. But V is volume of ball plus volume of water which was already in the beaker. If you see, this much is V, but that V is taken up by this particular sphere or ball as well as the water which was already inside. Now how much water is there? This much water was there, right? And this is 1/3 of 2r. This height is 1/3 of 2r. So volume of V is volume of ball plus volume of water which was already in the beaker. Volume of ball I'm going to keep as it is plus 1/3 of 2 pi r cube because only 1/3 water was there. Now I want to find out volume of ball. So volume of ball I take on left hand side, and on right hand side I get V, this V was over here, minus 1/3 2 pi r cube. When I solve this, there is no denominator over here. So when I solve this, this is what I get. 6 pi r cube minus 2 pi r cube upon 3. 6 minus 2 is 4. So I get 4 pi r cube upon 3. This 3 I can take with 4. So I'm left with 4 upon 3 pi r cube. So hence we get the formula of the volume of a sphere as 4 upon 3 pi r cube. Now we move on to practice set 7.1. Question number 1. Find the volume of a cone if the radius of its base is 1.5 centimeters and its perpendicular height is 5 centimeters. The radius r of cone is 1.5 centimeters. We start by writing the given information. Its perpendicular height h is 5 centimeters. And now we write the formula which we are going to use. They have asked us to find the volume of a cone. So the formula for finding volume of a cone is 1/3 pi r square h. Next step will be to substitute the values. So I have 1/3. First we need to check whether the units are in as the same. Only then we can proceed. So centimeter, centimeter, let us proceed. 1/3. The value of pi I'm going to take as 22/7. You can also take it as 3.14. Into, this is r square is 1.5 multiplied by 1.5 into h is 5. So after solving this, I get 82.5 upon 7. Then I divide it and I get 11.785. I can easily round this off to 11.79 up to the second position. And volume means the unit will be cube. So centimeter cube. And this is my final answer. Volume of cone is 11.79 centimeter cube. Question number 2. Find the volume of a sphere of diameter 6 centimeters. Diameter of a sphere is 6 centimeters. So its radius r will be half of it, which is 3 centimeters. I am asked to find the volume. So volume of a sphere 4 upon 3 pi r cube. In this case, I am going to take the value of pi as 3.14. So 4 upon 3 into 3.14 into r cube, that is 3 cube. When I solve this, I get 113.04 centimeter cube. That's my final answer. Question number 3. Find the total surface area of the cylinder if the radius of its base is 5 centimeters and height is 40 centimeters. The radius r of the base of cylinder is 5 centimeters and its height is given to me as 40 centimeters. First, total surface area. Total surface area of cylinder is equal to 2 pi r in the bracket r plus h. So I am substituting the values. 2 multiplied by 3.14 into 5 in the bracket. Please do not forget to put this bracket 5 plus 40. First I solve the bracket and I get, and simultaneously I solve this. So 3.14 into 10 into 45. When I solve this further, multiply this, I get 1413 centimeters square. This is total surface area. So the unit is centimeter square. Total surface area of cylinder is 1413 centimeters square. Question number 4. Find the surface area of a sphere of radius 7 centimeters. So the radius of the sphere r is 7 centimeters. Surface area of sphere, the formula is 4 pi r square. Now if you see, this is 7. So a wise way of solving this would be taking the value of pi as 22 upon 7. So 4 multiplied by 22 upon 7 into 7 into 7. 7 will get cancelled. I get 88 into 7. When I multiply it, I get 616 centimeters square because it's surface area. So centimeter square. Surface area of the sphere is 616 centimeters square. Next is question number 5. The dimensions of a cuboid are 44 centimeters, 21 centimeters and 12 centimeters. It is melted and a cone of height 24 centimeters is made. Find the radius of its base. Let us begin by writing the given information. The length of the cuboid is 44. Its breadth is 21 and height is 12 centimeters. This is of the cuboid. And for the cone, the height of the cone, h2. Now we have 2h. So this is h and this is h1. So height of the cone h1 is 24 centimeters. And they have asked us to find radius of the base. Since we don't know this, let the radius of the cone be r. Now this cuboid is melted and a cone is made. That means whatever was the volume of the cuboid, the same is the volume of the cone. So we have volume of cuboid is equal to volume of cone. Now let us write the formulae. Volume of cuboid is length multiplied by breadth multiplied by height. And volume of cone will be 1 upon 3 pi r square. But this height and this height is not the same. So we are going to mention this as h1 over here. Now let's substitute the values. 44 into 21 into 12 is equal to 1 upon 3 into 22 upon 7 into this we don't know. So we are going to keep as it is r square into 24. Now let's take r square on one side and we get 44 into 21 into 12 into 3 into 7 upon 22 into 24. And when I solve this by reduction and then multiplication, I get 21 into 21. R square is 21 into 21. So when I take cube root on both sides, when I take square root, I'll repeat, when I take square root on both sides, I'm left with r as 21 centimeters. Therefore, the radius of the base of cone is 21 centimeters. My dear students, we stop here. We will continue in the next video. Thank you for watching. Have a nice day.